an independent analysis of European defense capabilities and strategic policy.
In an era defined by the relentless pursuit of low observability and the rapid maturation of sixth-generation air dominance systems, the decision by Rome to authorize a procurement package valued at approximately 7.5 billion euro for 24 additional Eurofighter Typhoons presents a complex strategic juxtaposition. Superficially, this acquisition appears to be a reinvestment in legacy architecture, a move that seemingly contradicts the overarching trajectory toward the Global Combat Air Program and the continued integration of the F-35 Lightning II. However, a systemic analysis of the Italian Air Force force structure reveals that this procurement is less about nostalgia for fourth-generation kinetics and more about addressing a critical intersection of industrial continuity, operational mass, and the evolving doctrine of electronic warfare. The retirement of the 26 Tranche 1 Eurofighters, scheduled to conclude by 2029, creates an immediate capability vacuum that fifth-generation platforms alone cannot efficiently fill. While the F-35 offers unparalleled survivability and sensor fusion in contested airspace, its operating cost and logistical footprint make it suboptimal for routine air policing and lower-intensity interdiction missions. The structural logic of the Italian Air Force relies on a high mix of capabilities, where quantity possesses a quality of its own. Replacing the outgoing airframes with the latest standard of Typhoon ensures that the fleet maintains the necessary sortie generation rate to meet NATO commitments and domestic airspace defense, and without accelerating the fatigue life of the more sensitive and expensive stealth fleet. This highlights a constraint often overlooked in pure technological comparisons, which is that airframe availability often supersedes technological sophistication in day-to-day peacetime operations. Technically, the new acquisition represents a divergence from the air superiority role originally envisioned for the platform in the Cold War era. The integration of the ECRS Mk2 radar suggests a doctrinal pivot. The Typhoon functions not merely as a kinetic shooter, but as a high-energy electronic warfare node. Unlike the passive sensing philosophy that dictates the design of the F-35 to maintain stealth, the updated Typhoon is configured to operate as a high-power active emitter. In a contested environment, this creates a complementary tactical ecosystem. The F-35 can operate silently forward of the line, gathering target data and distributing it via secure data links. Meanwhile, the Typhoon remains at a standoff distance, utilizing its substantial payload capacity to launch long-range effectors like the Meteor missile or to unleash high-power jamming to degrade enemy integrated air defense systems. This teaming concept transforms the non-stealthy nature of the Typhoon from a liability into a functional component of a layered offensive complex. Furthermore, the decision to procure these aircraft carries significant implications for sovereign operational freedom. While the F-35 provides a quantum leap in capability, its operation is heavily tethered to the Autonomic Logistics Information System and the broader United States operational infrastructure. This introduces a layer of dependency that can complicate unilateral deployments or missions that may not align perfectly with wider alliance priorities. The Eurofighter, being a product of European consortiums, offers Rome a degree of mission data sovereignty and modification authority that is structurally impossible with the American platform. By maintaining a robust fleet of Typhoons equipped with the latest avionics, Italy preserves a mechanism for independent power projection and reduces the risk of strategic paralysis should diplomatic friction ever restrict the support for U.S. origin systems. From an industrial standpoint, this procurement functions as a critical bridge. It spans the potential valley of death that threatens the domestic aerospace sector, between the cessation of current production and the ramp-up of the Global Combat Air Program in the mid-2000s and 30s. The Leonardo facilities and the wider supply chain in Turin require a consistent workflow to retain the specialized human capital essential for advanced aerospace engineering. A hiatus in production would likely result in the atrophy of these perishable skills, forcing a costly and potentially impossible reconstitution of the workforce when the sixth-generation program enters its manufacturing phase. Therefore, the €7.5 billion investment must be interpreted not solely as the purchase of hardware, but as a subsidization of the industrial base required to guarantee Italy remains a principal partner, rather than a junior supplier, in the future fighter program with the United Kingdom and Japan. There is, however, an inherent trade-off in this strategy that cannot be ignored. The allocation of substantial capital to a non-stealthy platform in the late 2000s assumes that electronic warfare and standoff munitions can sufficiently mitigate the lethality of modern long-range surface-to-air missile systems, like the S-400 or its successors. It implies a calculated risk that the sheer kinetic loadout and electronic attack capability of the Typhoon LTE will remain relevant in high-intensity conflict scenarios where the electromagnetic spectrum is contested. If air defense networks evolve faster than jamming technologies, the utility of these platforms in a peer adversary conflict could be marginalized, relegating them to rearguard duties earlier than anticipated. This would result in a bifurcated air force where a small cadre of F-35s bears the entire burden of penetrating operations, potentially overwhelming their capacity. Moreover, the integration of the ECRS Mk2 and the associated avionics upgrades serves as a de-risking mechanism for the sixth-generation technologies destined for the future Tempest platform. By fielding these active electronically scanned arrays and open architecture mission computers on the Typhoon first, the Italian defense apparatus can mature the software and valid operational concepts in a lower-risk environment. This iterative approach to technology insertion suggests a preference for evolutionary capability growth, rather than relying entirely on a revolutionary leap that might face delays or technical bottlenecks. Thus, it reflects a pragmatic understanding of defense acquisition where the perfect is often the enemy of the good, and where an operational 4.5-generation fighter is infinitely more valuable than a theoretical 6th-generation system that exists only on a digital blueprint. In the final assessment, the procurement of the new batch of Eurofighters indicates that Italy is navigating a transition period characterized by high uncertainty. The strategy rejects a binary choice between the past and the future, opting instead for a hybrid force structure that leverages the distinct strengths of different generations of air power. It acknowledges the physical limits of a stealth-only fleet and the economic imperatives of maintaining a sovereign defense industry. While the platform itself traces its lineage to the previous century, and its internal systems and its role within the networked battle space are decidedly forward-looking. The success of this transition will ultimately depend on how effectively the Italian Air Force can integrate these disparate systems into a cohesive operational whole. Balancing the raw power of the Typhoon with the subtle lethality of the F-35, ensuring that the bridge to the next generation remains intact and functional for the decades required to cross it.